Um, Hello and welcome to today's class, Introduction to Programming. So we're basically going to look at the following as our learning objectives today. Actually, it's just one, so no need to panic. Right, so just going to look at the basic concepts of programming, as that is very important towards laying a foundation to you learning how to code and all that. So the basic concepts of programming basically revolves around giving instructions to a computer to perform certain tasks. All right. So these instructions that you're giving to the computer to perform tasks are what we call what? Are what we call code. All right. So in a nutshell, if you were to define programming, then we'd say that it's the process of providing instructions to a computer through code. All right. So that is what programming basically is, the process of providing instructions to computers through code. And so code is usually written through programming what? Programming languages. All right, so these programming languages will range depending on what you find easy to use and what you're working on. So we have example of them being Python, being Java, being C++, C Sharp, JavaScript, SQL, and etc. We have Ruby, Swift, and all that. But of course, in in this particular masterclass, we'll only focus on Python. All right. So code is written using programming languages. All right. So the key concepts of programming, as we discussed earlier, are going to be the following. All right. So the first one, we're going to look at variables. That's the first key concept of programming that you should understand if you're going to code. So what is a variable? So variables are used to store data or values that can be referenced or manipulated within a program, okay? All right, they are basically used to store data or values that can be referenced or manipulated within a program. Then the second concept that we're going to discuss here is data type. So these concepts we're discussing, we won't be able to um, show them within an example, but as we keep doing our lessons, you'll see them as the lessons progress. So we have what we call data types. So data types are defined as the type of data that can be stored in a variable, all right? So remember, variables are used to store data. And these data that are usually stored in variables are of different types. We have those that are numbers. So we basically call those what? Integers. That is if they are not decimals or fractions of numbers. And we have those that are basically, made of sentences, all right? So we call them what? Strings. Then we have floats and we have double floats and all that. And as I've said, we learn all this as we start doing our coding practically. The third variable we're going to discuss here is control structure. All right. So control structure is used to determine the flow of execution within a program. All right. So you write a piece of code and you want, let's say, for a user to key in his name before they're able to log in into the program. So what do you use? You use what you call control structure. And so control structure basically is the use of conditional statements, all right? And loops. Let's say you want something to be repeated all over and over, within a piece of program, all right? So you'll always use loops to do that. Uh, we learn all this, as I've said, practically within the program. Then we have functions, right? Very important. So functions are basically blocks of code that perform specific tasks. You may have a function that just performs summation of numbers. You may have a function that performs, differentiation of numbers and all that. You may have a block of code that, is used to verify and authenticate use of a program and all that. So basically, a function is just a block of code. And I've said we'll look at them into details with examples in our future classes, specific classes, specific tasks. I mean, so we have what we call input and output as well. So programs basically interact with users and other systems by taking in from the mouse, keyboard, and producing out, data, let's say with the monitor and all that. So input and output is part of programming, and you can actually decide at what point you want your program to take instruction or interact with the user or other systems, and actually write a piece of code to do that. Then we have what you call algorithm design, right? So basically, algorithm are step-by-step procedures for solving problems. Most of the time when you're coding, you're writing algorithms, all right? Uh, and so the step-by-step procedure that you use in solving these problems is what we call algorithm, all right? So and basically, when you're programming, we say that you're supposed to design an efficient algorithm you're supposed to design an efficient algorithm, all right? One that is easy to understand, read, reuse even with other codes. And also, the whole process of writing algorithm is a very fundamental aspect of what? Of programming, all right? So we have debugging and testing. So you write a piece of code, let's say it has an error, you need to fix it. That's what we call what? Debugging. So debugging involves identifying and fixing what? Errors. So these errors is what we call bugs in the code, right? And testing is also very important. After you've written, after you've written and developed a piece of software, and you want to make sure that it's working under various conditions and that it's not malfunctioning, doesn't have any malwares. So that's what we call what? For testing. So testing ensures that programs behave as expected under various conditions. All right. So that's also an aspect of programming that you should know of. We have what we call data structure. All right. Now this is different from data. Okay. This is different from not data but variables. So what data structure really does is that it organizes and stores data in a computer's memory, right? So does that so that it allows efficient retrieval and manipulation of data, right? When a program is running, it uses the RAM, all right, the active memory of the computer at that particular moment. And so the data that the program is using at that particular moment is usually stored within the RAM so that there is easy accessibility and manipulation of that data, right? So that is usually done, or that is done, using what we call what? Data structure, right? Within the program that you're writing, right? So some common data structures include arrays, linked lists, stacks, queues, trees, and graphs. Again, we look at all these in details as we continue with the class in the future. So we have what we call object-oriented programming, mostly used in Python. Not only Python, but also Java and JavaScript and all that. But object-oriented programming is a programming paradigm that is based on the concept of objects, which basically encapsulates data and behavior. So what object-oriented programming basically does is, let's say you are trying to write code for a user. So you'll treat the user as an object, and you realize that this user may have attributes like, he may need to authenticate himself before he accesses the program. Okay, okay. This user may also need a profile, all right, within the program. So is he tall? Is he dark? Let's say you're writing a program for a social media program. Okay, where does he live and all that, so you're going to maybe consider the location. Does he want to introduce himself or herself as male or female, or none of that? Does he want to maybe talk about their interest? So that is what object-oriented programming basically is that when you're writing a piece of code, let's say for users that are going to use your program, you focus on them and all the attributes that they come with, all right? So that is all done using object-oriented programming, and that is very important because it has certain principles that helps with coding, that is encapsulation, inheritance, polymorphism, and abstraction, which makes it easier to write that piece of code. So you don't end up repeating yourself. You don't end up repeating yourself every time you refine the user, as this piece of code can be inherited and all that. Okay, so as I said, we look at all these things practically as we commence on. So finally, we have what you call modularity. Okay, so Modularity basically means, that let's say you've written a long piece of code, okay, a long piece of code. And of course, as you know, when you're coding or working on a program, you need your code to be read and understood by other coders, because then it makes it easy to improve and yeah, and maintain your program. Okay. So what you do usually is you break it down into smaller and more manageable modules. Okay, so you break your program down into smaller and more manageable modules or functions that are easy to understand, maintain, and reuse. Okay, basically when you are collaborating with other users. So that is what modularity basically means: is that you take your long piece of work, long piece of code, and you break it down into modules. All right, or functions that are easy to understand, maintain, and reuse. Now, that's it for today's class. But before we close it, in conclusion, also we basically saying that these concepts that we've looked at, that is the basic concepts of programming, are very important because as they form the foundation of programming. Okay, so they are like the baby steps into programming, and they are also essential for developing software applications across various domains. Okay, we'll see them further practically in future classes. Adios. Thank you for your time.